Hi everyone, in this video I'm going to go through a practice problem where I find the mixed strategy Nash equilibrium in a game of the Battle of the Sexes. So in a previous video I went through the theory and the demonstration associated with finding all of the Nash equilibria in Battle of the Sexes. So I'll link to that video in the description and also up in the corner here. That video is much more explanatory than what I'll do here. In this video I'm just giving you another example and the solutions so you can practice the skills that I went through in that original video yourself. So I'm going to go through it pretty fast here, but I really encourage you to have a look at the matrix on the screen here, pause the video, do the calculations, draw it out for yourself, and then you can check whether you got it when you got it right. So here is my game. In this game, we have two players, Iroh and Sienna, who can play gardening or cafe. Iroh will choose to play gardening with some probability P, and cafe with some probability 1 minus P, while Sienna will play gardening with some probability Q, and cafe with probability 1 minus Q. And in the game, you can see that Iroh prefers gardening since they get that higher payoff of 5 if they both end up playing gardening, while Sienna gets that lower payoff of 3. And Sienna prefers going to the cafe. If they both choose cafe, then Sienna gets that outcome of 5, that's the highest outcome, whilst Iroh gets the 3. Both players really dislike it if they're choosing opposite sorts of activities. So you can see the 0 payoffs there if they choose different activities. So that's a fairly classic Battle of the Sexes game. I'm going to start by thinking about Iroh's expected payoffs, and we can start with, let's say, Iroh's expected payoff associated with playing gardening. So that's equal to, well, if Iroh plays gardening, they're on this top row. So with probability Q, Sienna will also play gardening, and Iroh will get a payoff of 5. So we have Q times 5, plus with probability 1 minus Q, Sienna will play cafe, and so Iroh will get 0. And this is all equal to, well, this guy cancels out, so 5Q. That's Iroh's expected payoff associated with playing gardening. We can do the same thing for playing cafe for Iroh. Iroh's expectation is equal to, well, they will be on this row here, and with probability Q, Sienna will play gardening and Iroh will get 0, so Q times 0. And with probability 1 minus Q, Sienna will play cafe and Iroh will get 3. So that all simplifies to 3 minus 3Q. We can then think about Iroh's best responses. So if the expected payoff associated with gardening is greater than the expected payoff of playing cafe, then Iroh should just play gardening with probability 1, so as a pure strategy, and that will mean they set P equal to 1. We can substitute in here our expectations, the values we found before, so 5Q, that's the expected payoff of gardening, and that will be greater than the expected payoff of cafe, which is 3 minus 3Q, and then we're just going to solve for this Q value. So we can add 3Q to both sides. We get 8Q is greater than 3. Divide both sides by 8. And we get this condition that if Q is greater than 3 over 8, then Iroh should just set P equal to 1. Just play gardening with certainty. All right, on the other hand, if the expected payoff associated with cafe is greater than the expected payoff associated with gardening, then Iroh's best response is to play cafe with certainty, which means setting P equal to 0. So substituting in 3 minus 3Q there, that will be greater than 5Q. We can solve for Q. I'll add 3Q to both sides. I then divide both sides by 8. So we get this condition that if Q is less than 3 over 8, Iroh's best response is to play P equal to 0. And hopefully you can see that if we then set the expectations equal to one another, we get this condition if Q is equal to 3 over 8, and that's our point where any P will be a best response. So I won't go through the algebra or the logic just because it's a bit repetitive. If you don't understand this step, you can go back to that first video that I spoke about before, where I discuss what's going on in detail. And actually, hopefully at this point, you can see, there are kind of shortcuts. Once you find that initial inequality, you've kind of found the point in which everything is happening. You can do things pretty quickly with practice. All right, that was Iroh. Let's think about Sienna's expected payoffs. And I'll start with what Sienna's expected payoff of gardening is. So if Sienna plays gardening, will be on this column, the first column, and with probability P, Iroh will also play gardening. and Sienna will get a payoff of 3. So we get P times 3, and with probability 1 minus P, Iroh will play cafe and Sienna will get 0. So this expectation simplifies to 3P. Let's think about Sienna's expected payoff of playing cafe then. We'll be on that next column, the second column, and with probability P, Iroh will play gardening and Sienna will get 0. And with probability 1 minus P, Iroh will play cafe and Sienna will get 5. So this simplifies to 5 minus 5P. All right, let's think about Sienna's best responses. So just like Iroh, if Sienna's expected payoff of playing gardening is greater than the expected payoff of playing cafe, then Sienna should just play gardening as a pure strategy, so with probability 1. So Sienna should just set Q equal to 1. Substituting in our expectations, this condition reduces to if 3P is greater than 5 minus 5P. Adding 5P to both sides, we get 8P is greater than 5. And dividing both sides by 8, we get this condition that if P is greater than 5 over 8, Sienna's best response is to play Q is equal to 1. We can think about the opposite sort of situation. If Sienna's expected payoff of playing cafe is greater than the expected payoff of playing gardening, then Sienna's best response is to play cafe as a pure strategy, so set Q is equal to 0. Substituting in, this condition reduces to if 5 minus 5P is greater than 3P. Adding 5P to both sides, we get 5 greater than 8P. Dividing both sides by 8, we get if P is less than 5 over 8, Sienna's best response is to play Q is equal to 0. So we have kind of the greater than condition, the less than condition, and at the equality, that's when our expectations will be equal. This is where any Q is going to be a best response for Sienna. All right, we've got our best responses. So let's draw all of it out. I have P on the vertical axis, that's the probability that Iroh plays gardening. And Q on the horizontal axis, that's the probability that Sienna plays gardening. And I've written out the best responses here on the right-hand side for us to look at. And let's start our diagram by putting in some important points. So I'll mark firstly when P is equal to 1 and when Q is equal to 1. Let's look at the best responses. I'll do Sienna's first in the purple color. So if P is greater than 5 over 8, then Q is equal to 1. So let's do this. If P is greater than 5 over 8. So 5 over 8 is just a bit over a 1/2, so I'll put it there. So for P greater than 5 over 8, Q is equal to 1. So find Q is equal to 1. Q is going to be equal to 1 if P is greater than 5 over 8. So something like that. We can make it neater later and all line up if that's what we need to do. If P is less than 5 over 8, Q is equal to 0. So it's going to basically be right on the axis when Q is equal to 0 over those P's less than 5 over 8. If P is equal to 5 over 8, then any Q is a best response. So we're going to go across all the Q's, and that's perfect. Let's think about Iroh's best response to Sienna's choices of Q. So, well, if Q is greater than 3 over 8, well, 3 over 8 is just less than a half, so it will be here. If Q is greater than 3 over 8, Iroh should play P equal to 1. So find P is equal to 1, and that's for Q's greater than 3 over 8, so something like that. If Q is less than 3 over 8, then P is equal to 0. So find P is equal to 0 for all Q's less than 3 over 8, something like that. And if Q is equal to 3 over 8, any P is okay. So let me do that, and that's it. So what we're looking at is our best response lines here that follow our players' best responses to all of the possible values of P and Q. We can see that there are 3 intersections of these lines, which correspond to our 3 Nash equilibria in our game. We have 2 pure strategy Nash equilibria, which are here and here. And at these equilibria, both our players will play gardening, they'll both do that together, or they'll both play cafe. So we can find these pure strategy Nash equilibriums just by looking at the matrix. I've got videos on that as well, but once you're at this point, you probably know how to do that. What we're really looking for is our additional mixed strategy Nash equilibria, which is here. And I'll write it out in the formal way. So I'll write player 1's play first, and that will be Iroh. So at this intersection of our best responses, Iroh plays gardening with probability 5 over 8. And so P is equal to 5 over 8, and cafe with probability 3 over 8. So I can tell the 3 over 8 because once we set P is equal to 5 over 8, then the probability associated with Cafe must be 1 minus P. So 1 minus 5 over 8 is 3 over 8. Likewise, Sienna, who's player 2, so I'll write their play second at this Nash equilibrium. They play gardening with probability 3 over 8, so Q is equal to 3 over 8. And Cafe with probability will be 1 minus 3 over 8, which is 5 over 8. So that's this game. I hope that you got it right. I hope that you're really confident now with finding mixed strategy Nash equilibrium. Thanks so much for watching my stuff, and good luck with your studies.